But we're going to look at today, for day 3, we're going to look at vectors and polar to start off the day. Specifically, so this is chapter 8 and chapter 9 material here. We're going to talk about how to convert from vectors to polar and polar to vectors. We'll talk about magnitude and direction, and then we'll talk about with graphs as well. So let's begin here. Number 4, it says, what is the polar equation that produces a spiral of Archimedes? And before I even start typing these in, I want you to recall that there were some special shapes. We have spiral. Another one is a rose. Whoops. Another one is a rose. You have a cardioid. We had a limacon. And we had a lemniscate. Okay, these were our 5 different shapes that we talked about with polar in lesson 9.2. Let's start off with, what does a spiral actually look like? There's the spiral. That one's the easy one. There's another one on there that's pretty easy. What's the other one that's pretty easy? A rose. That's just going to look like what? A flower petal, like a bunch of flower petals. So I'm a terrible artist, but yeah, basically there you go. You're going to have a bunch of flower petals going around. That'll be easier. Okay, now the ones that aren't as easy as these 3, you need to have something, a memory device to help you remember. What about cardioid? What do y'all remember about that one? It can look like a butt, or it can look like a heart without the point at the opposite end from the crack. So it could look like a heart or a butt depending on which way it's turned. Okay. What about a limacon? Very much like a cardioid. It just has an inner loop. So the way I mentioned it that day in class is I said a con in Spanish means with. This one comes with something. This one's like the cardioid, except it comes with a loop. So it's kind of like that. So instead of it just having the little crease where the cardioid would make it look like a heart or a butt, this one has it comes with a loop. Okay, which brings us to the lemniscate. Only one left. What was our other shape? What was that other shape? Francisco, you got it. Yeah, some people say infinity symbol, some people say figure 8. Others just say an 8. Yeah, and the right way I describe it is a lemniscate rhymes with 8. So if you see lemniscate, think 8. It's going to be like an 8. All right, so those are our 5 shapes. Now with that, on this exam, graphing a polar, that's equations with R, are the only things I recommend using Desmos on. So on School City, you'll have a window. You can pop open a Desmos calculator, and on that one, so let's pop open a Desmos calculator. We can type these in to see which one it is. What do I want to show you here? This is the one thing we will use the little that I would recommend Desmos for. The rest of it, we can just use our calculator. But if I go Desmos here, the one thing I want you to see is up in the top right where it has graph settings. There's a grid, and it kind of looks like by default right now, like kind of like an Excel document, a bunch of horizontal and vertical lines. That's talking about the background here. If you switch to the next one over, it'll give you polar, where you see circles and diagonal lines. That's what I want here. I want polar, and now I'll type these in. To get a theta, you'll type it in Theta. That's how you spell that, theta. You'll type that in for thetas, or if you go to keyboard and hit the ABC button, you'll find a theta on the ABC side of the keyboard as well. So here we go. I'm going to try the first one. The first one will not graph, and neither would it graph in this calculator either, but I'll try it anyways. I'm going to type it in. Theta equals 2 pi divided by 3. You'll see nothing happens. What this is, it's a diagonal line that goes through 2 pi over 3. So here's 2 pi over 3. This would be the diagonal line that goes all the way through like this, but it does not graph it, unfortunately. However, these will. If I graph these in, we can figure out which one's the spiral. So again, I'm gonna just type in theta equals 2. There's a graph. R equals sine theta. No, not R equals sine theta, sorry. R sine theta equals 2. There's a second graph. And finally, our last graph, r equals 2 theta. Do any of those look like a spiral? J. So obviously, J is the correct answer here. Could we do this in our other calculator? Yes, but I can't change the grid, which is a little unfortunate. So for graphing polar, that'll be the one thing I'd suggest using Desmos for. Here, I'll show you. If you go to graph, you can do menu, graph entry, and choose polar. But what you would have to do is you'd have to solve all of these for r. Like for example, you could not do r cosine theta equals. You'd have to know that you have to do your algebra and say, okay, to get r isolated, I got to do the opposite. What's the opposite of multiplication? Out of curiosity. Division. Yeah. If you were going to graph this in the calculator, you'd have to say, well, that is equal to r. That right there is equivalent to r equals 2 divided by cosine. You'd have to type it in this way to actually see that on the graph, but it will not change the background of the graph. You still would have got the same answer. So I'll just do the correct answer. We know the theta button, by the way, is where pi is. If you press pi down there in the bottom left, you'll find 2 theta. Press enter. That will give you a spiral. Let me go to radians so you can see it easier. That is a spiral there. So that is the correct answer. I would just recommend Desmos for polar. Everything else will be using our other calculators, but I'd recommend Desmos for that. All right, your turn. See if you remembered anything. If you got a DOL piece of paper, just a little blank piece of paper for something to turn into me, I want you to do your best to draw a cardioid, a lemniscate, a rose, then a limacon. I'm gonna pause the video here. All right, moving on. Number 19. So again, notice this is a polar equation, a polar graph. If it's a polar graph, you could use this calculator on it. I would not recommend to do so though. I would just use Desmos. So I'm gonna open up my little Desmos again and let me clear this out. And again, if you need to spell theta, that's how you spell it right there. Or you could find the theta on the keyboard, Desmos keyboard. If you press ABC, you'll find it right there. Okay, we want to know which equation is used to create that rose. So if you typed in the equations, r equals 2 sine 2 theta. Let me zoom in here. Is that a possibility? Yes, that's a possibility. I'm going to leave that one there. Let's try answer choice B. R equals 2 sine 4 theta. Is this a possibility? No, I'll turn that one off. What's wrong with that one? Too many pedals. Yeah, that one has a lot of pedals. That one's not it. So we'll turn that one off. That one's certainly wrong. R equals 3 sine 4 theta. What do you think about that one? Still too many pedals. So that one's wrong. I'll turn that one off. And finally, r equals 3 sine 2 theta. Wait, is that a possibility? Okay, so now I know which two to debate between. It's either A or it's D. It's one or the other. How can you know? You look off of what circle the maximum occurs on. So if you're counting circles up on this graph, this is circle 1, this is circle 2, this is circle 3. The blue, the answer choice A, comes on the second circle. Answer choice D comes on the third circle. When you check out this graph, what circle number is that on? That is the third circle. If you check this point out and you come back to here, you'll see this is circle 1, 2, that is circle 3. So the answer is D. The one that falls on the third circle has a 3 out in front. That's the magnitude right there. That right there refers to the magnitude. It is 3. It would be D. Questions over that? Again, I recommend Desmos. You could use this calculator, the Inspire for it, but Desmos, because it changes the background, I think it's just better. All right, switching gears. So that's the basic polar. That's the one thing I would suggest using Desmos for. You can use Desmos for as much as you want, but that's the one thing I would really suggest that I think Desmos is better for a test anyways on, is graphing polar. After that, there's a lot of things with polar and vectors that I think are extremely powerful and the TI calculator. So I want you to go to new document and don't save. Just clear out whatever's there and just hit add a calculator. Today, we're going to be on a calculator for the majority of the class. Here it says, what are the polar coordinates for this point 2, -2? And so it tells us, 1, we're looking for polar. What are the polar? That means these are polar down here. And it says this point. When it says point, that means it's an x, y, which you could also call rectangular. It's a rectangular. What we're going to do is what I'm going to suggest is show you how to convert this into that. Now, you might be going, why don't I just take this one and convert it and get my answer? Because if you remember this from chapter 9, there is only one way. There is one way to write an x and y point. There is one way to describe an x and y point. Or a rectangular point. Do y'all remember how many ways there are to describe a polar point? Who did their homework? There are multiple ways. Do you remember how many? I see a 2. It's not 2. I see a 3. It's not a 3. It's not a 6. It's 4. There are 4 ways to describe a polar point. A polar point. I'll do an h, theta point just to stay consistent. Okay, so what does that mean for us? You see how this is x and y? What I can do in the calculator is I can convert it to polar, but there's no guarantee that the answer is going to be there because it might not be the correct one of the 4 that they listed. So here we go. I want you, Peyton, make sure you're awake with me here. Take your calculator. Here's how you convert. Hit control parentheses. Control parentheses. So parentheses on our calculator, just so you know, are the programming. When it sees parentheses in our calculator, it thinks multiply. It does not think of a point. It thinks multiply. So we're not actually going to type in a parentheses. We're going to do control parentheses, which is that bracket. Now it knows it's giving you, you're giving the calculator some set of data. So press 2, -2. Now, if you type it in like that, the calculator will interpret that as an x and y, which is perfect. And we can try to convert this to polar to see if we can get our answer. How do you convert to polar? You'll want to just basically memorize this. You're going to press menu. You're going to use the number 7, which is matrix and vector. So menu 7. Down at the very bottom of the list under C, you'll see that C says vector down there. So it's going to be menu 7C and then 4 converts to polar. Menu 7C4. Press enter. Oh, and I need to pause. Let's check our mode. My calculator says radians. I don't know what mode you're in. Let's see what mode we're supposed to be in. The answer choices. Do you see pies for radians or degrees for degrees? Pies for radians. You need to make sure you're in radian mode. You don't have to type the whole thing in. Let's just say you were in degrees. Or in my case, I was in radians. If I wanted to find the other way, you would click that button right there to switch it. If you just press the up arrow, whatever you highlight, it'll copy it down if you press enter. So I'll highlight what we typed in and press enter. And if I press enter a second time, now it would give you the answer in degrees. See how that worked? So I'm going to change back to radians though. Okay, so it says the value should be 2.82. As I look on these, I don't have a 2.82, but I do have square roots. Let's figure out which square root is right. Is it 2 square roots of 2? Or is it 4 square roots of 2? Which one happens to be the correct decimal there? 2 square roots of 2. So we can eliminate F and G. And now, why can I eliminate J? The fourth. Okay, so you know this maybe by off the -45. Maybe you know your radians. But let's just say you don't know. What can be tricky about this is my point of writing this over here. You're like, why did he spend the time writing this? My point was to show you that if you start with an x and y and convert to polar, you might not ever get your answer straight from the calculator. However, if you plot the polar and convert to rectangular, it'll give you the answer every time because there's only one way to describe the x and y. So let me show you how you do that. This time, hit brackets, control parentheses. So again, control left parentheses to get that bracket. But this time, instead of typing in the x and y like we did, we're going to type in the h and theta. So do 2 square root of 2, comma. Oh, make sure the comma is outside the square root. Messed up there. Comma. And now we're going to type in the angle. However, I have to tell the calculator that it's an angle. Otherwise, it's going to think it's an x and a y. So press Control Book. When you press Control Book on the second row, third column, you have the symbol that represents an angle. If you press this, the calculator now knows you're giving it a polar point. Put in 7 pi is down the bottom left by the comma, 7 pi. I'm going to press Control Divide to get a fraction. 7 pi divided by 4. You do not have to do any special keys to convert it to x and y. The calculator will automatically convert it to x and y. When you just press enter, it'll convert. What does it say the x and y would be?
So this one do I have to take it to
That bracket?
the bracket?
The angle symbol? I did Control Book, and you'll see it second row, third column. Does H look like it's the correct answer? H look good or bad? Looks good to me. I think H is good. Okay, well, I'm going to check. Again, I'll check it now. Answer choice J. If I wanted to check J, what I could do, a shortcut here is just press up twice so it highlights that answer choice. Press enter. And now all I have to change is the 7 pi over 4 to a 3 pi. When I change that, what happens to my x and y? You see how the symbols changed here? Yeah, so J is clearly not right when you look at it this way. J is wrong. It's not the right answer choice. So we can not just say that J is not right because we can try it. Now we have tried it. We can prove that it is an incorrect answer. So here's my point in showing you this. The first time I converted the x and y to polar, when I did menu 7C4, that first time, let me scroll up here. It gave me this answer right there. That answer did not happen to match up any of my answers on there. I did not have a positive, even if we said, okay, that is 2 squared is 2. Well, even knowing that, they gave me a positive angle, I mean a negative angle right there. Did any of my answer choices have a negative angle? No. The calculator happened to solve for one of these 4 ways, but it was not the way that the answer choice was listed. So my point in showing you this is not to say do it both ways. I'm not saying that at all. What I actually say when you're taking this test, if you can just remember, there's more than one way to write an x and y. Is that right? What I just said? There's more than one way to write an x and y. That's not right. How many ways can you write an x and y? Only one. There's more than one way to write a polar. So what's the trick? Start with the polar, because the polar, if you type in with start with polar, it'll give you the only x and y, and you compare that one. So when I typed in this polar, H, it was the only polar. Let's find that spot right here. When I typed in H, it gave me the only rectangular option for it, which happened to be the correct one. Does that make sense? So if we were going to do this again, I would not start with the x and y in the problem. I would start with the answer choices because they're polar. This is the one where you could have, whoops, where's my writing? This is the one where you could have multiple answers. So I would start with the polars and I would convert them to rectangular. And that you just have to press enter on. You don't even have to do the menu 7C. I think rectangular is maybe 3, something like that. You don't even have to convert it. You can just press enter and it does automatically. Are we clear on that? Sure. I want to give you another one here in a little bit. You're positive, you ready? Positive, you remember? All right, here you go. Point P is rotated 210 degrees counterclockwise around a circle with a diameter of 20 meters. Notice I have taken away your unit circles. So you're taking this test and you're like, oh no, I don't have a unit circle. Have no fear. First question I have for you. In my classroom, have I spent any time hardly whatsoever throughout the year talking about diameters? No. What do I talk about instead of diameters? Radiuses or radii. A radius, how does it compare to a diameter? It's half of it. So this says the diameter is 20 meters. What's that make its radius? 10. Okay, in terms of polar, you can list this point right there in polar as saying it has a, let me move polar right here. If I list this as a polar, I could say remember polar deals with circles, that this has a radius of 10, that's my R, and the theta is 210 degrees. Now, if I want to type this in the calculator, I can't use a parenthesis. What do I use instead of a parenthesis? Let me clear all this out. I use a bracket. How do I get that bracket? Control left parenthesis. Our R is 10. And I'm going to do comma 210. If I press enter, right now I have done two things wrong.
Negative. Change back to degrees.
First, got to change to degrees. Mine says rad for radian. That means it needs a pi. I don't have any. Change it to degrees. That's number one. There's something else I've forgotten. I got to tell the calculator it's an angle. Right now it just thinks it's 210 Ys. It's not 210 Ys, it's 210 degrees. How do I tell it's an angle? Control book. Control book, put the angle symbol there. Luckily for you, you don't have to press any buttons to convert to rectangular. If you just press enter, it should do it automatically. When you press enter, what value? Just round. What are y'all getting when you press enter?
8.6. Well,
Negative 8.6 and -5. Look at your answer choices. I'm going to go off the -5. Which one looks like it's going to be the correct answer choice? F. Okay, let's double check with F. Let's check -5 squared to 3. Let's make sure that matches that right there. -5 square root 3. Did they match? Boom. Do you even need a formula chart? Do you even need, did I say formula chart? Sorry. Do you even need a unit circle to do these problems in?
No.
No. If you can remember to use a calculator and just type it as a polar and convert that polar to rectangular by pressing enter, that'll do it. Oh, and let me make one more connection. Just to help make sure you remember this. You remember when we were doing tic-tac-toe? Chapter 8, chapter 9, we were doing tic-tac-toe stuff. Okay, on tic-tac-toe, we were listing this as X, Y, H, theta, and then a lot of times we were doing 1, 2, and R, if you remember that. Well, this problem only has one value, so it doesn't even have a 2 and R. But what we started off with is we knew the H or the radius, R and H are the same thing. R and H happen to be the same thing, was 10, and my angle was 210 degrees. If you use the formulas X equals H cosine theta, and you type that in individually, it would have said this value is the -5 I'll do it this way, -8.6. I'll say -8.7. And then the Y is -5. That's what we just learned there. The calculator just does that really fast for us. That's what it just did. So you can connect some dots what just happened. It just solved for the X and the Y. By the way, if X is H cosine, what was Y? H sine. Or you could say R sine, whichever one you want, H or R. Good. All right. Your DOL. Number 14, DOL. So that just means put on your other sheet of paper, but it's just like number 14. You won't find it on your packet. Obviously, a bunch of scratch work there. I want you to try this one around to 1 decimal place. 1 decimal place this time. All right, let's take a look now at number 15. So number 15, I don't know if you remember when we did this, adding up vectors. This is technically the true symbol for vectors. This is a 3-dimensional vector. That would be an X, a Y, a Z, X, Y, and Z, X, Y, and Z. This problem says, what is 1/3 of vector A minus 3/2 of vector B plus 2 of vector C's? The calculator will do this ingeniously as well using those brackets. So go to your calculator. I want to just clear mine out. So I'm going to type this in, and what you have to do though is press Control Divide for the fraction. I'm going to do 1/3. But for this bracket, you could do it by hand if you wanted, just distribute through that 1/3. What I'm going to do here is use the vector. Now, there's one thing you must do. Like if I do control vector right now, I'll type this in, -6, comma 12, comma -9. Now, if I press enter right now, it won't work. It says error, too many subscripts. The problem is the 1/3 right here, for whatever reason, the calculator doesn't know what it's supposed to do with the 1/3 and this vector. What is supposed to happen with this 1/3 and the vector? It's supposed to distribute, which is a way of saying it's supposed to be multiplied. As long as you hit the multiply, it'll work. So we're going to take 1/3, and I'm going to just type in the rest. Minus 3 halves. I should have done it as a fraction of 3 halves of b to -16, comma 18. And I'm intentionally making a mistake. Some of you might be waiting for it. I did intentionally. Plus 2 bracket 28, comma -14, comma 3. Now I typed all that in. If I press enter, it should give me my answer, but it says error, too many subscripts. What did I not do? I need to do to make this math work. What did you say there? Peyton, I can't understand what you're saying. Hey, Jaden, can you sit up for me? You mind taking off your hoodie? I feel like you're just trying to sleep on me. There's a problem. I told you on the first, it has to do with what I did here, what I did not do over here. You gotta put multiply. So as long as you put multiply every time, it should work. If you don't do multiply, it will not work. So go ahead, hit that multiply, and tell me which answer choice do you get when you've done that? You're getting A. Let's see. I press enter. 51, 0, -24. I totally agree. The answer choice was A. Okay, you want me to do it by hand? Absolutely. If you're gonna do it by hand, you're gonna distribute through. You'll distribute through here. Whoops. If I did this by hand, what do I get? I will, 1/3 of A will become, when I distribute this, it'll be a -2. 1/3 of 12 is 4. And -3, that's correct. And then I do the same thing with -3 halves of B. If you distribute this through -3 halves, you multiply by -3, which is a -6, then you divide it by 2. And so, yes, it is a -3. Positive 24 and 27, -27. Okay, and then finally, you would add 2 of C. Oops. I don't understand. You asked me to do it by hand, then you're just yelling out the answers before I can even write. All right. You did say 56, -28, and then finally the one y'all did not say, 6. And then you would just add these up, going down the columns. So basically, it's 56 -3 -2, which is 51. From there, you could add those together. It's 28 -28, 0. That's a -30. Add 6. That's a -24. And that's how you would get that answer there. Yep, by doing it by hand. Okay. All right, 17. If R has an initial point of -3, 1 and a terminal point of 1, -1, which graph represents -2R? Okay, let's first figure out where these 2 points would be and what vector R would look like. So initial means the starting point, terminal means the ending. That must be a vector because it's moving. Vectors have movement. It starts in one place, it moves to another. So plot the point -3, 1. I'm just going to use my graph here at A. -3, 1. Where is that located? Which quadrant? 2. So I go left 3, up 1. There's the initial point. That's where the graph starts. Where does it end? Right 1, down 1, quadrant 4, right there. That's where this point ends, terminates. So this is a vector that moves from the top left to the bottom right in this direction. Now I'm going to erase my points so you can see the arrows more clearly. That's what the graph's supposed to look like. Now we said want to know which graph represents -2r. And so I want you to remember a couple things with vectors. If you were to multiply a vector by 2, it just basically means have 2 vectors tip to tail back to back. If you were going to do a negative, what it does is it flips the vector the other direction. So let me clone this, and I'm going to flip it and flip it again and change the color. Properties. It's taking longer than I thought it was. Okay, there it is. That right there is a -r vector. You see how they're the same length but pointing the opposite direction? So if you had 2 of those, let me have 2 of those tip to tail, your answer should look like what I have there in green. It should be a vector that's pointing this direction, going 2 of those in length. Now, which one's the correct answer? See, now notice it doesn't, they started theirs over at the origin. It wouldn't have to be there. You could do it like where I have mine. Whoops, that's not what I wanted to do. I wanted to move this and this one. You could really have them anywhere because that's the vector. It doesn't matter where it's located. You could locate it wherever you wanted. You could put it at this point. You could put it at the origin. You could put whatever you wanted. But either way, the graph has to look like this in green, and that's what a C is. Tip to tail. Notice that is the right answer. Okay, so that's how you'll do that. The graph starts at the initial and it ends at the terminal. Hey, Angel, you have headphones in? Oh, okay. Thank you. All right. Let's now move into some for real tic-tac-toe. I earlier showed you how the calculator was doing that math, how it was doing the tic-tac-toe. That's what it was doing. Now let's actually start doing that stuff. When you come to problem number 7, problem number 7 gives you 2 vectors. How do they know they're vectors? It's because I'm seeing these solid lines with an arrow at the end. That is a vector. This one right here is just showing you the horizontal line. Ignore that. That looks like a vector itself. Probably would be better if you just kind of thought of it like this without that vector even being like that arrow being there. There you go. That's probably a better way of thinking through this problem. Okay, whenever you see more than 2 vectors, there's probably going to be tic-tac-toe. If you see the word resultant, it absolutely is tic-tac-toe. So I'm going to draw 4 by 3. So you can go ahead and do this with me. Draw 4 vertical lines. 1, 2, 3, 4, and then 3 horizontal lines. 1, 2, 3. Remember to leave your first square blank and then put X, Y, H, theta. Down this left side, 1, 2, and R for resultant. This H is different from this. This R represents the resultant. That's why I do a capital. This H could be the radius as well. So it could be R or H, but typically we do an H. Okay, the first question you ask yourself when you look at vector number 1 here is you ask yourself, is it a horizontal X? Is this a vertical Y? Or is it a diagonal H? Okay, that didn't answer the question. Is it a horizontal X, a vertical Y, or a diagonal H? It's an H. This is diagonal. It's going to be placed as an H. So we'll put 15 here. Now on the angle, you need to ask yourself, is the angle a positive angle or a negative angle from the x-axis? Okay, so this would be a positive 20 degrees from the x-axis. It's very key for tic-tac-toe that you go from the x-axis. And positive if it goes up, negative if it goes down. The second vector, Mark, you're saying this 12 is also a diagonal H. Do y'all agree or disagree with him saying that 12 should go into H? So this is diagonal. You're saying that is diagonal. I agree. That is diagonal. It goes there. the angle. It says it's 27 degrees. Do you agree with the diagram saying 27 for the calculator? Negative, because this one's going downward. So we're going to put negative 27 degrees. Now here's what the calculator does real nice, is you don't have to, remember when we were doing all this algebra by hand, what we were doing those days is we were saying this is H cosine, this is H sine, and then this was Pythagorean theorem. Whoops. X squared plus y squared. H is the square root of x squared plus y squared. And this is inverse tangent. Now, our calculators can do this really fast, and we don't even have to find those values. How? By using these brackets. So I'm just going to clear this, get some space here. I'm going to do control parenthesis to get the bracket. This is a polar. That's polar right here. So I'm going to do 15, comma, and I want to type in 20. At this stage, I've done at least something wrong, possibly two things wrong. I did not do an angle symbol. This thinks right now the calculator would think that's an X, that's a Y. It would think it was these two values. To make it know that it's polar, you have to do the angle symbol. Okay, that's number one. The other thing I have not even said to check is the mode. Is my mode correct?
Yes, it's in degrees.
Mine's in degrees. Yours might be radians. I don't know. Check your mode. You can just click them, by the way, if I didn't say that. Just click it, it switches. We need to be in degrees. Okay, if you wanted to fill in the X and Y here, you could press enter. Honestly, you don't have to. What you can do is just add this one, because that's what a resultant is. It adds up these vectors. So I'm going to add the second vector. So I'm going to do another vector. And this time I'm going to do 12, comma, negative 27. Will this work? Did that work? No, why not? Because the way I have it typed in, the calculator would think it was an X and a Y. Are these X's and Y's? No, you need the angle symbol so it knows it's a polar. Control book, angle symbol. Now, when I press enter this time, it gives me the X and Y that go right here. By the way, you would not even have to hit enter there. I'm getting 24.8 for the X. The Y, I'm getting negative 0.3. But you wouldn't even have to press enter. What you could have done, whoops. What's going on? Here you go. What you could have done is from here, just press menu, 7 for matrix, C for vectors, and then 4, convert to polar. Menu 7C4. If you do this, it'll give you the magnitude and the direction, the H and the theta. And that's what we're supposed to find here is the magnitude. We were asked to find the magnitude. We just found out the magnitude is 24.8, and the direction in degrees is not even negative 1 degrees. It's approximately negative 1 degrees. That's pretty crazy how close it is to the x-axis. But so the magnitude, which one's the magnitude? 24.8. So the answer is B. Little vocabulary review. If they only wanted the X, what word would they use? Horizontal. They would say horizontal if you were supposed to find the X. They said horizontal component. There you go. My board's messed up on me. Okay, what would they say if they wanted the Y value? Vertical. Very good. This one, we just found it. It's magnitude. What if they wanted this very last value? What would they call that? Starts with D. Not distance. Direction. There you go. That's the direction there. Those are the 4 words that they might ask for. All right. I want to give you all a chance in here in class. I'm going to pause this and see y'all work this, and then I'll come back on and work it in a second. Okay. I want you to try to do number 13 here. using tic-tac-toe and all that. All right, let's take a look at this. So first it says an airplane flies east for 200 miles. I want to pause. East, which way, directionally speaking, is east? Up, down, left, or right? It's to the right. So it looks like this: north, east, south, west. Vector 1 says the airplane flies 200 miles east. And then it says before, that means it's about to do something else. So 200 miles to the east like this. Now, technically, if I wanted to draw this right, I would go tip to tail and I would start a second vector at this tip. But I'm not going to do it that way. It says before turning 60 degrees south. Well, that's an English way of saying it was heading east. And now that it's turning, that means it's east 60 degrees towards the south. So it's east 60 south like that. That's what turning 60 degrees south means. So the second vector here, I was going east, so technically I should be doing it there. I'm going to go back to the origin though. I was heading east, but now I'm turning 60 degrees south. Tell me when you think I've gone 60 towards the south. That's about 45. I'll keep going. I'll stop there. Okay, so there's east 60 degrees south. I'll add on that 60 degrees here. This is 60 from the east to the south. And it does that for 100 miles. So 100 should be on this vector. So if you wanted to solve this, you would do a little tic-tac-toe. And I would suggest on the test, you only have a couple of these. I would suggest doing a quick sketch and doing the tic-tac-toe. Having both of those just on a piece of scratch paper, just to make sure you keep your variables and values straight. So up at the top, leave the first one blank: X, Y, H, theta. 1, 2, R, and that's for the resultant. So as you check over your vector, by show of hands, how many people had a drawing somewhat similar to this? Just out of curiosity, how many people actually drew and had something similar to that?
I drew on the side of it.
Not that many people. Did you just not draw at all? Oh, okay. 200 here. Would we call this 200 an X, a Y, an H? What is that 200? Is it a horizontal X? Is it a vertical Y? Or is it a diagonal H? It's a horizontal X. It's flat. It's flat, so I would put it in the X column. You could use it as an H with 0 degrees. I saw some students do that. That's fine. I think it's easier just to go X here. What's the Y value then? 0, because it's flat. Okay, that's vector 1. Let's talk about vector 2, the turn. This 100, would you call this an X, a horizontal X, a vertical Y, or a diagonal H? It's diagonal. So you put 100 in the H column. The direction is the 60 degrees. For the calculator, that's negative because the calculator always goes from the east, working north, west, south. It goes around this way. So that'd be a negative 60. So if I go in my calculator, all I have to do is add these together. And it says, what are the magnitude direction? That's the polar values. It wants to know what are the polar. So we're going to type these in and press menu 7C4. So when we were doing this by hand with algebra earlier in the year, we would convert everything to X and Y, which the first one's in. We would convert this, then we'd add the X's and Y's, then convert to polar. Well, the calculator can do everything for us at once. If you just do control bracket, 200, comma 0. At this stage, the calculator believes it's an X and Y because I did not hit the angle symbol. And that's what it's supposed to be, X and Y. I'm going to add vector 2, which is control bracket, 100, comma. Now, again, if I just hit negative 60, I need to check one, I'm in the right mode. But if I just left it as negative 60 without the angle symbol, it would think that the X is 100, the Y is negative 60. We need to make sure the calculator knows it's an H and theta. So you put the angle symbol, control book, hit the angle symbol. Now this will add the values together. Since I need menu, magnitude, and direction, instead of just pressing enter, I'm going to press menu 7C4. Menu 7C4. Now I'll press enter, and that's the answer converted to polar. It says the magnitude is approximately 264.6. And the angle would be negative 19 degrees. Again, that angle is going from the east, negative 19 degrees. So as I look at my answer by magnitude, I can eliminate answer choice A and answer choice C. Those two are out. So now it's either B or D. D looks tempting because the number is correct.
But it's not right.
It's not right, is it? Because where's the calculator give you the answer from?
It's not the reason. It's just given from east to south.
A calculator always gives from the east since it was negative. That is east 19 degrees south. That is not the form they gave it to us. We need to go from the south. And so you would just take that away from 90. 90 minus 19 would be 71 degrees. So it's south 71 degrees east. And there's my answer. Just a rounding difference is all. B would be the correct answer. Okay, so that is how powerful these calculators can be. I would highly recommend doing a drawing because that's half of it. Just make sure you have it drawn right. But the calculator can handle all that math for you really easy. All right, let's see what we're left off on here. I'm gonna let you try one. Let's see what you come up here. All right, let's take a look now at number 23. So 23, I tried to get a little tricky here. And I tried to see if I could just confuse anybody based off. Well, let me ask this. You're taking the test and you see this problem. As you even try to interpret the type of problem is, what do you see the diagram looks like? What do you call these things with arrows? We call those vectors. So this has, how many vectors do you see? 3 vectors. What I want you to do here is draw what I normally would say is a 4x3. This time it's going to be a 4x4. Draw a 4x4. Jaden, keep that up, please. A 4x4. If you're wondering why a 4x4, that's because we have 3 vectors. And so when I get to the left side, I'm going to write down a 1, 2, 3, and then an R. This word resultant also gives it away. When you see resultant, you're doing tic-tac-toe.
You just kind of.
We could, but first, let's write this out. Up at the top, I want to have X, Y, H, theta. Okay, this first vector, if you were looking at it, does it look like an X, a horizontal X, a vertical Y, or a diagonal H? What does it look like? Diagonal H, thank you. Does it give you the value for H? No, but you know what it did give us? The X and the Y. Here's the only problem. It says the X is 18. If you put an 18 there, you will not get the right answer. It's a negative 18. Why is it a negative 18? It's going to the left. What would that make the 15? Positive or negative? Positive, and for Y's, that's a positive. Okay, so that's this vector. What about this second vector? Why both positive? Right and up. So X, Y, 5 and 6. Okay, what about this one? It's a negative. And I'm gonna put that on the Y, negative 100. What do you put for the X if it doesn't go left or right? 0. And so now from here, you just add them up. What is 18, negative 18 plus 5? Negative 13. So this one, it just said, what's the component form? That means the X and Y. If they wanted magnitude and direction, you could go to your calculator, press menu 7C4, but that's how you do that. Questions over that one? So I think, is that it for polar? Nope, one more. During a scouting exercise, Andrus leaves camp and hikes 2 miles northwest. I'm going to draw what I would highly recommend you do on the test is give a little drawing. You don't have to go tip to tail. Honestly, I think sometimes it's easier for doing tic-tac-toe if you don't. Northwest, which direction is that? Is that in the top right, bottom left, top right, top left? Top left. Okay, 2 miles northwest. Never eat shredded wheat. Okay. Soggy waffles. Okay. Hikes 2 miles northwest. He then turns and hikes 3 miles due north. So again, if you want to draw it tip to tail, go from there. That would be the proper drawing. I'm not going to draw it properly. I'm going to go from here. So I'm going to say 3 miles due north. Goodness. 3 miles due north. Felicia plans to leaves camp and plans to hike on a direct path to Andrew's new position. What direction should Felicia hike to the nearest 10th of a degree? Okay, so let's do our little tic-tac-toe 4x3. This one only has 2 vectors, so I only need 3 horizontal lines. 1, 2, 3. X, Y, H, theta. This is the first thing Andrew says. That's the second thing. And this would be Felicia's resultant vector. Okay, vector 1, this 2. Would y'all call that a horizontal X, a vertical Y, or a diagonal H? Diagonal H. So 2 goes there. Northwest. We got to think of what is northwest in terms of degrees from east for the calculator. Well, how many degrees is it from the east to the north?
It looks like it's approximately 0.5, 0.5, so you add 9 plus 45 equals.
Northwest is 45. That's right. Northwest would cut the 90 degrees between north and half. So that would be 45. So what is 45 plus 90, did you say?
135.
135. That's going to be our angle from the x-axis, 135. Second vector, 3 miles north. So if it's 3 miles north, is that a horizontal X, a vertical Y, or a diagonal H? What are we saying? What do you think, Juan?
Vertical one.
Vertical Y, I agree. If you use a Y, you have to include the X with it. What are we going to put for X here? 0. So those are our 2 vectors. We want to know the direction. Is that part of rectangular or is that part of polar? Polar. So we're going to do a menu 7C4 on this. Again, if you want to go step by step, you doing it by hand like we did earlier in the year, you would convert these, add up X's and Y's, then convert it over. I'm just going to use a calculator, let it do the work for us. Control parentheses, 2, comma. One more time. If I only do a 135, it thinks the X is 2, the Y is 135. To let it know that that is an angle, you have to press Control Book, angle symbol. Now it knows, oh, that's a magnitude, that's a direction. So we're going to take that vector, we're going to add it to the second vector that Andrew Squawk due north. So 0, 3, it recognizes that as an X and a Y. To convert your answer, you press menu, 7 for matrix, comma vector, C for vector, and then 4, convert to polar. That's their value. .6 and 107. It says to the nearest 10th of a degree. Would I say 0.7 or 0.8? 0.8. Okay, that's coming from the east around what direction? Here, they don't say, they should have said like what directional angle or something like that to let you know from the x-axis. This would be my answer. 107.8. If I left it like that, would that be correct if it was a paper test? Would that get you credit?
No.
No.
2 years. Oh, yeah.
You have to bubble it. 107.8. Would that get me credit? You don't have to actually put the positive.
Yeah.
That would get you credit. What would this give you credit? Yes, it would. It still would. All they care about are those bubbles. I've actually had students through the years that told me, nope, when you get your credit, you gotta take away all the white. Now that might be more ideal, but you don't have to do that. But if you want to get really specific, you can really spend a lot of time bubbling. You don't have to do that, but it doesn't hurt to make sure you stay online. Put that up there. Oh, there was one more I forgot. All right, easiest way to do this one. This point right here. What is that? Polar or rectangular? Polar, because it has degree symbol. Go over here, press Control, parenthesis. The value is -2, 330. Now, if I press enter like this, there's a problem in the calculator. How does it think I just typed it in? Thinks it's X and Y. That's the angle 330. So control book, angle. When I press enter, what does the calculator automatically convert it to? Rectangular. This is the rectangular value. It says it needs to be left 1.7, up 1. That's an X, that's a Y. Which one's left and up? Which point is left and up? Okay, this is the correct answer right here. So that's the way you could do this. If you forgot, how does that work? Well, what this means is go 2 circles away from 330. So here's 330. You, instead of going 2 circles towards it, you actually go 2 circles away from it. And that's why the answer choice is J. That is a wrap for day 3. I'll give you a DOL. Let me make sure. Yep, that's a wrap for day 3. Given this polar coordinate, find the other 3 polar coordinates. The other ways you can write them, actually, how about this? Give me the rectangular coordinates instead. For this value, give me the rectangular coordinates. And we'll call that the DOL.